And let's not put a window behind there so I can't screw it up. There we go. So we tackled a slope and a slope application problem with BMX. High jump, we talked about if I have two relationships, two pieces of data that I want to pair together, I can put them together into an ordered pair. And in this one, the data points were the weight of a bike and its jump height. We discovered as the weight increases, the height jump decreases, or the jump height decreases. And we got an idea for slope. So now we're going to take this over to graphing. All right. So let's make sure everything's working. Yes. So we have 3 lines here. We're going to graph them all on this plot. The first one is 2x plus 3y equals 6. The next one is x equals -3. And the last one is 2y equals 4. These are all different, just different lines, okay? None of them is quite like the other. So if I want to graph a line, and I know it's a line, I know it's a linear equation, so the 2 variables and the power of y is 1, the power of x is 1. That means I would love to find the x-intercept and the y-intercept, assuming they exist. Why would I like to find those two? Because if I can find the x-intercept and the y-intercept, then I can, they're very easy to work with, they're very easy to plot, and they're easy to find. So to find the x-intercept, I let y be 0. Okay? And now I plug it into the equation of the line. So I have 2x plus 3 times 0 is equal to 6. 3 times 0 is 0. So I have 2x is equal to 6. I'm not going to change colors. I think we can deal without them. X is equal to 3. And now I know that I have the point. Y was 0, x is 3. So this is the point 3, 0. Okay. Everybody good with that? That was my x-intercept. And now I'm going to go after my y-intercept. And to find the y-intercept, we let x equal 0. Why are these points good to use? Because to find them, one of the variables has to go to 0. Instead of plugging in, like, when x is 1, what is y? I know if I plug in 0 for x and find y, I can find my y-intercept. If I plug in 0 for y and solve for x, I can find my x-intercept. Sorry for the yawns. We have a puppy that doesn't like to sleep or doesn't like to kennel. It's just been a long week. 2 times 0 is 0. 0 plus 3y is 3y. 3y is equal to 6. Divide both sides by 3. Y is 2. From all this work, I've been given the point 0, 2. Can everybody follow along with that? How I got 3, 0 and 0, 2 based on the equation, based on that problem, the number 1. Everybody okay with that? Okay, remember silence. Remember, yes, good, okay. Silence in math class means you understand and are bored, and we need to move on to a more difficult topic. All right? So, plot, okay, good. Plot that. When you're doing this on a piece of paper for a turn-in or just doing it for your own notes, take the time to either find a straight edge and use it or make a straight edge. I literally have 2 rulers right here within my reach. I also have a big old stack of paper, and you can take a piece of paper, fold it long ways, fold it short ways, once or twice, and use the crease as the edge. It works, but it makes all the difference in the world. Trying to freehand a straight line, just don't do that. There's no need. Okay. The second line looks totally different, doesn't it? And the reason is it is totally different. This is a specific kind of line. If you don't know what kind of line this is, then don't change anything about anything about how you're going to attack this problem. Okay, so I'm going to find the x-intercept. I'm going to do that by letting y equal 0. All right, y equals 0. Y is not a part of this equation, is it? Y is not in there. Exactly. Since y is not in there, that means the equation just writes as x equals -3. So I have found the point -3, 0. Now, if I go after the y-intercept, this is where I let x be 0. If I let x be 0, I find that 0 is equal to -3, which is false. Right? 0 is not equal to -3. If I end up with something that makes no sense, it means the thing I'm looking for doesn't exist. So this means there's no y-intercept. If there's no y-intercept, if you don't hit the y-axis at all, you have to be parallel to it. If you're parallel to the y-axis, then that means you are a vertical line. Okay? So this means I'm looking at a vertical line. And we know that from the form of the line, x is equal to -3, one y is missing. I have a vertical line. I still need 2 points though. So if you're not comfortable with a vertical line at -3, you can find another y value to plug in. So I'm going to let y equal, let's do 2 here just for fun. You can be anything you want to, because if y is 2, x is -3, because that's just the equation that I got, x equals -3. So now this gives me the point -3, 2. I'll plot those, -3, 0, out to -3, don't go up or down, and then -3, 2, -3, and then up 2. My lines, my points are right on, they're vertical from one another. So that means I did it right. And of course, it's not gonna, no, of course it's not gonna land directly on it, but you get the idea. All right, so there's that line. The last one is the other side of the coin. 2y equals 4. You are allowed to manipulate this, solve it for y, solve it for x, however you want, or solve it for y if you want to. You can just leave it alone too. Okay. For my sake, I'm going to leave it alone. I'm going to do this one in green or in red, so hopefully it's easy to tell apart. I'm going to follow the same process. I'm going to find the x-intercept. And again, I'm doing this for completion, for people that are missing class today, not because I expect to see all of this work every time you do one of these. If you already know what this is, then you can go ahead and start working around it. So if I let y be 0, I'll find the x. I'll find the y is 0, I need to find the x coordinate. So let y equals 0, solve for x. 0 equals 4. Well, that's false. So that means what? There's no x-intercept. If there's no x-intercept, and the x-intercept, remember, is the horizontal one. If there's no x-intercept, that means I have horizontal line. All right, so let y-intercept. Find that y-intercept by letting x equal 0. If x is 0, then 2y equals 4. So both sides by 2, y equals 2, and I'm given the point 0, 2. All right, so I have 1 point. I need 2 to draw my line. So I'm going to do what I did before. Whenever you have a horizontal or a vertical, I'm going to let x be 1. All right, if x is 1, 2y is equal to 4, which means y is equal to 2. So I have the point 1, 2. So there are my 2 points, 0, 2, and 1, 2. 0, 2 actually happens to be the same point that we found for our y-intercept for the first problem. And then 1, 2 is right beside it. I now have 2 points, which means I can draw a straight line through them. And there they are. Okay. Now, I said you can manipulate on this step. If 2y is equal to 4, divide both sides by 2, I will find that y equals 2. And we know that is a horizontal line. We know that x equals -3 is a vertical line because x is there but y is not. And then anything that has x and y in it is going to be, could be anything except for vertical or horizontal. All right. Questions there? Anything? Feels like an old math class now, starting to click on some old stuff. So here's just a general sketch of what you have or the kind of lines you're going to see. You're going to see a slanted line. They don't have to be exactly at that angle. Good. They don't have to be at that angle exactly of, you know, going up or going down at that side. It's just saying a slanted line just means it's not horizontal, it's not vertical. I held my pen wrong for that. It's not horizontal, it's not vertical. All right, so if you got x and y in there, you've got a slanted line. If you're looking at a case of y is equal to some number, which is what we had for our second one, for the red one, then you have a horizontal line. Y is equal to some real number k. And then when x is equal to some real number k, I'm looking at a vertical line. So yeah, like I said, I found the x-intercept, the y-intercept, if they existed, and then found a third point if I needed it. Once you get the feel for y equals 2, that's all the points where y is equal to 2. Y is equal to 2 here and every single point along this line. Once you get there, you're good, but I think in my experience, students have had a hard time finding a second point for the line. So I always encourage you to, instead of trying to teach you to deal with this problem a different way, I'd rather teach you to do this one the same exact way you do the regular ones with the slanted lines. And then that way you don't get confused or make a mistake. All right. So now we're going to move on over to slope-intercept form. This is a huge deal for algebra and for graphing, because it turns out that if I give you the equation of a line, and remember, right now, what we know about lines is they can be written in the general form ax plus by equals c, where a, b, and c are typically integers, and a is non-zero, b is non-zero. All right, so that's the definition of a linear equation. All right, now, if you take a linear equation and write it in the slope-intercept form, which is y is equal to mx plus b, then it turns out the slope and the y-intercept are sitting right there for the taking. Okay, so if you take a general form line and you solve it for y, so in this one, I would subtract ax and then divide everything by b, I would then have my slope-intercept form. Why is it called the slope-intercept form? Because the slope is the coefficient in front of the x, and the constant term is the y-coordinate of the y-intercept. Okay? But it has to be in this form right off the bat. So let me give you an example. If I give you 2x plus 3y equals 6, we just saw this one earlier. In this form, what's the slope, what's the y-intercept? I do not know. Okay, I don't know the slope and the intercept because they're not, it's not the coefficient of anything, they're just not given, they're not told. So what I want to do is, if I want to find the slope, I'd have to get 2 points and then do the slope equation. I don't want to do that. So I'm going to rewrite this, or I'm going to do some algebra here and get this equation into slope-intercept form. So that is negative 2x plus 6. You could also do 6 minus 2x, that's fine. Get y by itself, that's my goal. Why would I want to do that? Because once y is by itself, negative 2/3 x plus 2, from this equation, now the slope is right there. It's negative 2/3 because they told me that. And then b is 2, which means that the y-intercept is the point 0, 2. Does that make sense? This is why slope-intercept form is so neat. If you can solve for y, the slope and the y-intercept are sitting right there as the coefficient of x and the constant term, and you don't have to go hunt them down by finding 2 points, finding the slope, and then chasing the slope all the way down until it finds the intercept. All right, so let's take a look at some examples. Here, all of these are actually in form already. Use the property to find the slope and the y-intercept of the lines. Y is on a side by itself, so the slope is the coefficient of x, not including x. That is a huge, that is a very, very common mistake that people make. They think the slope is 2/3 x. It's not, it's just the 2/3. Okay? And then for this one, b is negative 5, which means the y-intercept is the point 0, negative 5. For me, the y-intercept is always a point. It's not just a number. It's not just negative 5. But if you're asked what the y-intercept is and it doesn't accept it doesn't let you type in a point, and you type in negative 5 for this one, for example, and it says you're right, then just know in your mind the y-intercept should always be a point. All right, next one. All right, well, I have y and x, so I've got a linear equation, and it's slanted, right, because y and x are both here. It's not horizontal, it's not vertical. But there's nothing in front of the x. I don't have a coefficient. That doesn't mean the slope is 0. It means that the slope is actually 1. Right? If you have a variable sitting by itself, there's an understood coefficient of 1 sitting there. It's also sitting over here in front of the y, but we just don't care. Okay? Now, what's the slope? Well, the slope is the coefficient of x. The coefficient of x is 1. The y-intercept, or the b value, is positive 4, which means the y-intercept is the point 0, 4. I do want you to think about the y-intercept for a second and why this works. So remember just a bit earlier we were finding the y-intercept by letting x equal 0. Well, if x is 0, what happens in my original equation? If I let x be 0, this term goes to 0, and I'm just left with y equals 4, which leads me to the y-intercept, 0, 4. Do you see how that works? I let x be 0, and I solve for y, that lets me find the y-intercept. So when I get to this equation, if I can get that term to go away with the x in it, I'll be left with the y-coordinate of the y-intercept. And then lastly, over here, y equals 2x. Slope is easy here because m is 2. Y-intercept may not be so easy, so let me add something to it. I have y equals 2x. Is y equals 2x and y equals 2x plus 0 the same thing? 0 plus 2x is still 2x, right? Whenever you do one of these and you find that I have a coefficient for the variable, I have my slope, but doesn't look like I have an intercept, that means b is 0. And when b is 0, I still get a y-intercept. And that y-intercept is 0, 0, or the origin. All right? Questions? And then there's one more over here to the side. Y equals 6. In this case, yeah, it's starting to feel familiar. Good. So my last case, I know this isn't formatted super well for this, but we'll deal with it. All right, y equals 6. When I have this, okay, what's missing this time? Okay, I have the constant terms. I have my b, but I don't have the x coordinate in here. So I know this is a horizontal or vertical line. Which one is it? When I have y by itself with no x, is that horizontal or vertical? So it turns out it's horizontal. And why is it horizontal? Because it has a slope of 0. 0x plus 6. Yeah, horizontal, exactly. Right? Same thing that was happening over here on the other one. On the first one, I have y equals 2x. I can write 2x plus 0, and that turns out to be my y-intercept, turns out to be the b value. When I have y equals a constant, and there's no variable, no x variable here, well, it turns out that the slope is just 0. And then the y-intercept, or b for this one, is 6, which means the y-intercept is the point 0, 6. Cool? So it shows you if you can get y by itself, the slope and the y-intercept are super easy to pick out. And then with the slope and the y-intercept, you can graph your line. All right, you can graph the line that you're given using the slope and the y-intercept. Any questions? All right, I'm going to do this one, then I'm going to let you do the one on the next page, and we'll see how we do together. Given 3x plus 4y equals 4, find the equation in slope-intercept form, determine the slope and the y-intercept, and then graph the line. All right? So, slope equation. Get this in slope-intercept form. Why would I want this in slope-intercept form? Well, for this case, because it told me to do that. Slope-intercept form means solve for y, or get y on the side by itself. So I have a linear equation. Everything that has what I want by itself, what I want to solve for, which is y, needs to go to one side, and everything else needs to go to the other. Okay? So that means the x term needs to be taken to the other side. How do I do it? Well, it's currently added, so I'm going to subtract it. 3x minus 3x is 0. So now I have 4y is equal to negative 3x plus 4. Y is almost by itself. I just need to get rid of that 4, right? That 4 in front of the y. So I just divide this term by 4. If I do it to one term, I have to do it to all of them. And when I do that to all of them, what happens? 4 divided by 4 leaves me y is equal to, this is negative 3 divided by 4, which is negative 3/4 x, plus 4 divided by 4 is 1. All right, so there's my slope intercept form. Next part, determine the slope and the y-intercept. The slope is the coefficient of x once y is on the side by itself. So my slope here is negative 3/4. You'll see how I wrote the slope, or how I wrote the negative 3 divided by 4. I didn't write this as negative 3x over 4. I wrote it as negative 3/4 times x. The reason for that is I think writing it this way makes it really obvious that the slope is just the number in front, just the coefficient, and not 3x, negative 3x over 4. So that's why you see me do that. The b value here is 1, which means my y-intercept is the point 0, 1. So let's plot 0, 1. And then we're going to chase the next point using our slope, right? Because remember, slope is average rate of change. So if I know one point that's on the line, I can follow the slope and I know I'll hit the line again. All right, so my slope is negative 3 over 4. Now remember that this means change in y over change in x. Okay. So the numerator tells me how far up or down to go. The denominator tells me how many places to go left or right. Whenever you have a negative fraction for a slope, I always throw the negative in with the numerator just to make sure I don't try to do it twice. So the change in y is minus 3. So it means go down 3 points. 1, 2, 3. Okay? So there's the change in y, and I'm not going to write that out yet. Okay? So down 3, but then the 4 in the denominator is positive because the negative one with the 3. So a positive 4 in the denominator, that's my change in x. So that means go 1, 2, 3, 4 points to the right. And here is the next point. That is a point on the line. So this is change in y. This is change in x. Now, what if you wanted to do it the other way? What if you wanted to start here at my intercept of 0, 1, and you wanted to apply the negative to the denominator instead of the numerator? Okay? If math is universal, this better hold. So let's see if it does. So instead of going down 3, I go up 3. 1, 2, 3. The negative is applied to the denominator. So the denominator is 4. So that means move left or right 4 units. But because the negative is going with the denominator, that means I'm moving left 4 units. 1, 2, 3, 4 units. And take a look at those points. Are they all on the same line? Absolutely. And this is why having a third point can, if you're doing a test and you're just not super confident with your answer, adding a third point in will let you know, okay, yeah, everything's lining up. So again, change in y, change in x. Okay? So there's our line. And now it's your turn. Okay? So I'm going to go away. I want you to do the same thing for the problem on the next page. If I give you 2x plus 4y is equal to 8, I want you to find all things, follow the directions here, get this in slope-intercept form, find the slope and the intercept, and I'll pop off, and then we'll come right back in 3 minutes. All right, so it is a coincidence that 0, 2 seems to be popping up a lot for y-intercepts. And then to follow the slope, remember again, slope is change in y over change in x, so the change in y, and let that be -1, the change in x is 2. So this means if the change in the numerator is -1, this means down, and then to the right, change in x is positive, that means go to the right. So down 1, and then right 2. 1, 2. Here's my next one. And we'll make our line. Anybody run into issues with that? Or is everybody okay? Again, not perfect. My line seems to have some limitations on landing exactly where I want it to. Okay. Now, in general, for problems like this, if we want to just do a, if we don't have time to do a full check and make a third point, do all that stuff, the other thing you can do is take a look at and make sure that the line is falling or rising correctly. We found the slope here to be -1/2. A negative slope means my line is going to be falling from left to right. And this one is, right? So I'm falling from left to right, and my slope is -1/2. That is not a very large at the magnitude. Okay, -1/2 is very close to 0. And remember, a slope of 0 means a horizontal line. So I'm at -1/2, so I'm falling, but I'm not falling super fast. The larger the magnitude, the more gradient, the steeper the slope is going to be. So if I had a line with a slope of -6, it would be much steeper. Still falling from left to right, but it would be doing so steeper. If I had a positive slope, I should see a rise from left to right. And then again, in that one, if my slope is between 0 and 1, it's not going to rise any higher than 45 degrees. If my slope is over 1, then I expect my lines to get steeper and steeper. All right. Questions? All right. How do we feel? How are we doing? Good. Good. Okay. All right. So we have done everything we're supposed to. And now we're going to come down here. I'm going to introduce you to this. This is just a notation change. Instead of having lines and horizontal lines and vertical, or horizontal lines and lines, we're now going to call them functions because they are functions, right? Linear equations that don't, or you can't hit more than twice, so that removes vertical lines. Every other linear equation is a function, right? For every x, there's exactly one y. So if I have a slanted line, I've got y equals mx plus b. That's a linear equation. Well, now this is being called a linear function because we added f of x in place of y. Okay, so when you see this, this is a linear equation, and it's the slope-intercept form to be exact. And when you see this, y gets swapped out for mx plus b. Now you have a linear function. Same thing for the constant there. Y equals some number. This is a constant. Equation. And f of x is equal to b. Is a constant function. Not a very useful function for the constant one, because what's inside the parentheses has no impact on the right-hand side. But I just want you to get used to when they swap back and forth, if they call it a constant function, then they're using that notation, function notation to name it. If they're just calling it a constant equation, then they're just going to use y equals b instead of f of x. Okay. Now I have one last example here, and it says to write the equation of a line that passes through the point 2, -3 and has a slope of -4, and then write that linear equation using function notation where y is equal to f of x. All right. Anytime you're told to write the equation, oh, how so? Where is the confusion? Was it the function stuff I just did? Yeah, okay. So it's just a matter of, it's kind of like your name's Emma, but you always sign on as Tenny. So I always call you Tenny in class. Both of those are valid, right? And this is just one way to say it. This is the other way to say it, right? Whenever you use function notation, you have a function. Whenever you don't use function notation, you have an equation. So it's bringing in that function title, and then always right beside it in parentheses is the independent variable. Okay? And then the same thing down here. Constant equation, constant function. So, good. So let's deal with this problem. Here we go. So to write a linear equation, and anytime you're told to find the linear equation, it's always understood that you're going to write it in slope-intercept form, just like Andrew did in the comments there. To do this, you need two things. I need the slope, and I need a point, but for slope-intercept form, a point or the y-intercept. Okay, well, they gave me a point, they gave me the slope, I know that, and they gave me a point, which is this. So I'm going to take this information, I have the slope, I have a point, I do not know the y-intercept though. Now, some of you are thinking, oh, y is equal to negative 4x because the slope is negative 4, so it goes in place. Let me actually write the equation. I'm doing something over here and it's going to be wrong. So you'll see me write FSOC. And this says, for sake of contradiction, which means I'm about to do something wrong on purpose. Okay? The slope is negative 4, and then the point is 2, negative 3. So if I'm asked to write this as a linear equation or a linear function, all I gotta do is just plug in everything I know. Well, y is equal to the slope, which is negative 4, plus b, which is minus 3. Okay, people like to do this in the same way that they like to divide by, you just strike terms out. So this is wrong. And the reason it's wrong is negative 4 is the slope, that's correct. The y-intercept is not negative 3. Is not 0, negative 3. How do I know that to be true? Because when I get negative 3, when I plug in 2. So I can't use that. All right? So what do I need to do? I need to find b. So I got y equals mx plus b. If I have a point and I have the slope, I can plug all of the information in and then find whatever's left over. Well, the point is 2, negative 3. Moving back 2 steps. And then the slope is negative 4. Plug all that stuff in. Y is negative 3. M is negative 4. X is 2. And then do math. Negative 4 times 2 is negative 8. Get b on a side by itself. Everything with a b to one side, everything without to the other. And then, oh, don't add 5. I was giving away the answer here. Add 8. And negative 3 plus 8 is 5. Negative 8 plus 8 is 0. So I'm left with b is 5. Now, 5 is not the answer to this question either. The answer to this question is the equation in slope-intercept form. Now, remember, x and y are in final equation. Do not plug in numbers for x and y here. Just plug in the slope and the y-intercept. And I know those to be what? I know the slope is -4 from above. I know the y-intercept, I know b is 5. So that means my equation is y equals -4x plus 5. And there is the equation of the line that passes through the point to -3 with a slope of -4. All right. There is another way to find the equation of the line, and it's on the next page. And then, let me finish this problem up. And it said, write this in function notation. Again, this is the, instead of calling you Lawrence, instead of calling me Lawrence, you call me Larry. Y is a valid name for this relationship, and so is f of x. So just to go over from linear equation to, and let me put in parentheses and say in here, this is a, to be super clear, this is a linear function now. And then what's above is a linear equation. Okay? It's really easy to think that when we name things or we learn the vocabulary that they don't mean anything or that it doesn't really matter. It really does, right? Understanding the difference between an equation and an expression, a linear instead of a quadratic, that's usually the difference in passing and failing. Because if you don't understand the old stuff, then when I add new stuff on top of it, you still don't understand. When I say solve this or isolate this variable, we need to know what those mean. All right. So there's our function notation. We've solved it. If I give you a point and the slope, you can now find the equation of the line passing through that point with the given slope. Next is, this page is just notes, or this page is just this picture from the book. The problem with slope is not every equation is a linear equation. It doesn't have a constant rate of change. It may rise or fall faster or slower than a typical linear equation does. For example, we see right here at the bottom, my function is the line y equals f of x, which is blue. You see how it's got a curve to it. It's not straight. Okay? Well, I want to find the slope of the line passing through 2 points on that function. I want to hit the function in 2 places and draw a straight line through those 2 points. That line is called a secant line. Okay? You are probably familiar with a tangent line, where it's a line that only touches the curve once. It's the famous one. It gets all the attention. Okay? And then the secant line is the not so well known cousin. Right? It's like the Jonas Brothers and then their fourth brother that no one knows about. Tangent line is the one that everybody knows about. Secant line is not. Secant is when I hit a curve twice. Now, that secant line is going to be a straight line. It's going to be linear. And the slope of that secant line is the average rate of change for the function f. So, if I want to know the average rate of change of my function, that's the blue line, and notice that we have a little bit of information here. If f is defined on the interval x1 to x2, and it's got brackets, so it means endpoints are included. So is f of x defined over that entire interval? Yeah, there's no holes, there's no problem. And the average rate of change on that interval, okay, that interval is from x1 to x2, is the slope of the secant line containing, now they throw in a bunch of points here, it looks like it could be confusing. x1, x2, f of x1, f of x2. This is just giving you, instead of writing it as x1, y1, x2, y2, they're writing it as x1 comma. When I plug x1 into the function f, I get out my y value that's corresponding to it. When I plug in my x2, I get out whatever I find when I plug in f of x sub 2 to f. So the equation of the slope looks like it changes, right? Slope, we've been used to change in y over change in x. Well, when we get to a function, we don't have y. We have y sub 2 is whatever f was when I plugged in x sub 2. Y sub 1 is whatever I plugged in, whatever I got out when I plugged in x sub 1 to f. The denominator stays the same, it doesn't change. So it's the same exact equation. It's just got new names, right? It's just switching up. It's just think of it as a nickname or two things that you're both known by, right? My dad's name is Larry. He never called me Larry. He called me Boy or Du Bois or something else because he didn't like to speak of himself in the third person. So that is another name that I respond to. Same thing here. Y sub 2 is the same thing as f of x sub 2. All right, so let's go after an example. So here is a curve showing you blood alcohol concentration for an individual over a 9-hour period. We can see we're not told when this person stopped drinking, started drinking, any of that stuff. But you can see that blue line is not a straight line, it's a curve, right? It rises and falls. So it's not a line. Remember, lines only rise or only fall. They have a slope, they have a single slope. So I'm asked to find two things. I'm asked to find the average rate of change of blood alcohol from x sub 1 is 0 to x sub 2 is 1. Okay? And that just means from 0 to 1. So from the start until 1 hour in. Rate of change is, remember, is the slope. Well, the slope is the change in y to the change in x. Since this is in function notation, we'll be very nice and change our setup to, instead of y sub 2, we have f at x sub 2, f at x sub 1. Now, from 0 to 1, so let's swap out all of our numbers here. X2 is 1. X1 is 0. X2 is 1. X1 is 0. What is f at 1? Well, if I come up here, when x is 1, f of x returns 0.06. F at 0, when I plug in 0 for x, I get out 0 for y, so that's just 0 over 1 minus 0. 0.06 over 1, which is 0.06. It's blood alcohol level over time, but they didn't give me units. It's not, it's a percentage blood alcohol content, so I'm guessing, I mean, you could say the average rate of change over that hour is 0.06. That's how much the alcohol level went up in the body. Now, let's do the same thing, but let's change our x sub 2 and x sub 1. And again, I know I say this a bunch. I am writing out more than needs to be written if you're comfortable. That's f at 2 minus f at 1 over x sub 2, which is 2, minus x sub 1, which is 1. It's a coincidence that the 2 and the 1 are the subscripts down there, because that's not what always happens. As you can see right here, x sub 2 is 1, x sub 1 is 0. F at 2 is 0.09 minus f at 1. Well, I know that from the last one was 0.06 over 2 minus 1. 0.09 minus 0.06 is 0.03. 2 minus 1 is 1, and I have found my blood alcohol content, or my slope, to be 0.03. What does this mean on the graph? On the graph, this is the slope. My 0.06 is the slope of the secant line passing through the points. Oh, we're having a problem with the internet. Okay. Oh no, you're right. It's this. Okay, yeah, it's slowing down. It's going to peak and then it's going to start to fall. Right? Blood alcohol content is not a linear equation, or you would just continue getting more and more drunk over time. So I got 0.06. So that 0.06 is, see this purple line right here going through those 2 points? It's the slope of this line. Okay? Now, the next one is the slope between 1 and 2. It does, yeah, it's very dependent on the person. That's the slope of this line. Now, if you look at these lines, you're going to say, wait a second, that's a really steep line. But you said that slopes, if it's a really steep slope, it's really, slope is a very large magnitude, then it's going to be a very steep. And then if it's a small magnitude, it's going to be small. 0.06 is small. You're absolutely right. But look at the units up the left-hand side. This is not a one-to-one setup. It's not 1 hour is 1% blood alcohol. It's 1 hour is 0.02. So even though this slope looks small for this, for the kind of function that we're looking at, it's steep. All right. Any questions? All right, then let's tackle this last bit, and we're going to get away from that application, and I'm going to give you f of x. I'm going to ask you to find the average rate of change from x sub 1 is 2 to x sub 2 is 0. Average rate of change is slope. Ooh, any cases where this won't work? If the line is vertical, it's not a function. So this notation wouldn't hold. So I can't think of anything right off the top of my head. You can always pick terrible values for x and make it look like, right? If I pick, I start at drinking at 0, I end this at 0, and I find what's the average rate of change for the blood alcohol from when I started drinking to when I was completely sober, I get a slope of 0, and it would look like I didn't drink at all. Okay, so average rate of change, secant lines especially, the closer together the points are, the closer your slope is going to be to the change in that nonlinear function. To get this, I need f at 0 minus f at negative 2 over 0 minus negative 2. Now, I don't have a graph this time, but I do have a function. Okay? So I'm going to come out here to the side and indicate if f of x is x squared plus 1, then f at 0 is 0 squared plus 1, which is 0 plus 1, which is 1. So f at 0 is 1. And then the other one I need is f at negative 2. F at negative 2 is negative 2 squared plus 1. Negative 2 times negative 2 is positive 4. Positive 4 plus 1 is 5. F at negative 2 is 5. And those inform my slope. F at 0 is 1. F at -2 is -5. Sorry, it's 5. What am I doing? 1 minus 5 over 0 minus -2 is +2. 1 minus 5 is -4. -4 divided by 2 is -2. So for the function x squared plus 1 from -2 to 0, my slope is negative. So that means my function is falling from left to right at an average rate of -2 units. And remember, slope is change in y over change in x. So this is for every 1 move or 1 unit change in x. If I move to the right 1 unit, I'm moving down 2 units. All right, that's 1-4. Done. Any questions? No? All right. Quickly, I'm just going to show you 1-5. We're not going to get very far into it, obviously. No, just 1-4, because we won't be able to get 1. Well, I'm going to leave it there, because 1-5 is very short. So I want you to give it a shot, because the only new piece of information in 1-5 is the slope. If you find a line and you know its slope, find the slope that's find the slope of a line that's perpendicular, find the slope of the line that's parallel. So take a look at 1-5. You've got the blank notes up, and there are videos in there as well. So give it a look over. Definitely finish 1-3 tonight, 1-4 by next Tuesday, and then we'll see how 1-5 goes next week. Do all you can in there, and if it's too much left over, we'll extend it to Thursday. All right. So let me show you really quickly what this is after. Ignore this top for a second. We'll come back and deal with that next time. If I have a line and I want to find another line that is parallel to it, those two lines have to have the same slope. So if slope 1 and slope 2 represent the slopes of two non-vertical parallel lines, then the slope of m sub 1 is equal to m sub 2. If the slopes of two non-vertical perpendicular lines, then m sub 1 is equal to, this is the opposite. Oh my goodness, that's way too thick. This is the opposite reciprocal, right? M2. Okay, and what does it do? It goes from, so it's M2 is, if M2 is just sitting there, its opposite reciprocal is, it's in the numerator, move it to the denominator, and then change the sign out front. So that's why you don't hear me just say the reciprocal is the opposite reciprocal. If M2 is positive, its opposite reciprocal is negative, and everything changes places. So if I had 3/4, if m is 3/4, and I want to find the slope of a perpendicular line, that little upside down T means perpendicular. That means I would have what's in the numerator goes to the denominator, what's in the denominator goes to the numerator, and the sign changes. We've got -1/2. A line that is perpendicular to this would look like what? So it's 2 over -1, but then I have to put the negative out front because it's opposite reciprocal. 2 divided by -1 is -2, and -2 is 2. Okay? So take that with you, see what you can do, get all of 1314 done, see what you can do in 15, and then I'll see you all on Tuesday, and we'll finish up 15 and hopefully have a better calendar ready. All right? Okay, if you got any questions, stick around. If not, go be safe, and I'll see you all next week. Hayden, did I get it?